So now let's assume that the heights of all Manheim Township high school students are distributed approximately normally with a mean of 67 inches and a standard deviation of 3 inches. Let's sketch the model below and indicate the mean values 1, 2, and 3 standard deviations above and below along with their percentages. So we're going to draw everything that we need to include within our normal distribution curve. So again, start off with that axis there. Get our curve drawn, and right in the middle, we want to have our mean. So that, as we were told, was a height of 67. Then our standard deviation is 3. So we're going to go 3 above, 3 standard deviations above, and each of these we're increasing by 3 inches. So 67 plus 3 is 70. Add another 3 to get 73, and then our last one is 76. Same thing for below. We're just going to subtract 3 this time. We'll get 64, 61, and 58 here. Now, if we want to label all of our percentages, we're just going to use those nice rounded percentages that we've already gone over. So we've got that 34% in the first group, 13.5, 2.35, and then our 0.15. I should include the percentages on those. Now let's see what percentage of students are between 64 and 73 inches tall. So if we're looking for 64, that's 1 standard deviation below. 73 is 2 above. So we've got to add everything that falls within these 3 groups here. So we've got 34 plus 34 plus 13.5. So I'm just going to say we had 2 34s. So 34 times 2 plus that 13.5 is equal to a total of 81.5% falls somewhere in that range. So now what percentage of students are shorter than 64 inches? So you've got 64 here. And if we're looking for shorter then, we want to include everything to the left-hand side there. So we get our 0.15 plus our 0.235 plus our 13.5. That is going to add up to a total of 16%. Next, we've got what percentage of students are taller than 70 inches. So this one, we've got our 70 right there, and we have those same 3 numbers. So our 13.5, 2.35, and our 0.15, which we just added up. So it's going to be the same thing, 16%. So we're just comparing it to different sides of the graph. So this group right here, 16% above that 70, which is the same thing as that 16% below the 64, which should make sense because they are both 1 standard deviation away. So they should have the same amount above and below those 2 values. And what value of students are between 61 and 64? That one's nice and easy too. We don't need to do any sort of addition there. We can just read straight from our graph. We've got that 13.5% fall between that 61 and 64 inches. And then our last up, we've got 67.5 and 70 inches. So that's close to this interval right here, 67 and 70, but we can't say for certain anything definitively because we don't know where 67.5 would fall within this range. We know if it was just 67, we'd have 34%, but that 67.5 will fall somewhere around there. So we can just say this is going to be less than 34%. If that whole group was 34%, 67.5 is going to make it a little bit smaller there. We can't say anything for sure, but that's going to be the best answer that we can give. Less than 34% fall between those 2 heights. Okay, let's run through one more example together. So let's say, assume the time it takes you to drive to school is normally distributed with a mean of 10 minutes and a standard deviation of 0.5 minutes. Sketch the model below and indicate the mean values and values 1, 2, and 3 standard deviations above and below the mean along with the percentages. So again, let's start off drawing our curve here. Now let's just plug in what we do know. We've got our mean is that 10 minutes, and then each standard deviation is just going to be another half a minute here. So we'll draw our 3 above and our 3 below. 10.5, 11, and 11.5. On the left-hand side, we'll get 9.5, 9, and 8.5. And again, let's label those percentages. It makes solving a lot of these problems much easier. We can just read right from our graph. So we've got our 34%, our 13.5%, and our 2.35%, giving us and then our 15 or 0.15%. And then let's just mirror that on the left-hand side again. Now we can use everything that we just labeled and answer some of these questions here. So let's see, on what percentage of days will it take you longer than 10 minutes? Well, 10 minutes was our mean, and we know that falls directly in the middle of a normally distributed curve. So everything above that is going to represent 50% of our data. So we've got 50% of our days. Now, what percentage of days will it take you less than 10.5 minutes? So now for this time, we're going to add up everything that falls below our 10.5. So we could add our 0.15 plus our 0.235 plus 13.5, and then those 234s. I'm going to do this a little bit of a shortcut though here. So we can say 10 is again our mean. So we know below our mean is 50%. But we're looking for below our 10.5. So I'm just going to take the 50% below the 10 and add that extra 34 there. So we could say 50 plus 34 gives us everything below that 10.5, which is equal to 84%. On what percentage of days will it take more than 11 minutes? Well, if we're looking for 11 minutes, everything that falls above 11 is that 2.35 plus our 0.15 is equal to 2.5% there. And what percentage of days will it take between 9.5 and 10 minutes? So 9.5 and 10.5 minutes is one standard deviation below and above. It's just these groups of, or two groups of 34, which is going to give that 68% that fall within one standard deviation. So 68% of days. So now let's see number 6 here. We've got what percentage of days will it take between 8.5 and 9.5 minutes. So now we've got 8.5 here and our 9.5 here. We're going to add up these two groups here, our 2.35 plus our 13.5 to give us 15.85%. Let's see, approximately 95% of drive times will fall between how many minutes? Well, we know 95% represents 2 standard deviations away. So let's look at our curve. We'll go to our 2 standard deviations, our 9 and our 11 there. So everything within those 2 standard deviations is going to represent 95%. So we can say 9 to 11 minutes. Name 2 intervals that explain 34% of your drive times. Well, that one's nice and easy. That's going to be the 2 intervals that are 1 standard deviation above and below our mean. So we've got the interval below would be 9.5 to 10 minutes. and then the interval above is going to be that 10 to 10.5 minutes. Those are just the two groups of 1 standard deviation above and below. And then let's name 2 intervals that have 85.1% of all your drive times. So 85.1 is a little bit more of an awkward number, but I'm thinking we just saw that number pop up in that last example. So let's take a look at that one really quick again. That 81.5 came up for this number 2 here. So that was 64 and 73, which was 1 standard deviation below and 2 standard deviations above gave that 81.5. So we can say if we have 1 standard deviation away on one side of our graph and then 2 standard deviations away on the other side of our graph, that range is going to give us that 81.5%. So looking here, we're going to do the same thing. We could say 1 below this direction and then 2 above on that direction gives us that total group of 81.5%. Or we could do, for our second group, let's do 1 standard deviation above here and then 2 below on that way. So that's going to give us the 9 to our 10.5, which will also give us that 81.5%. So the 2 intervals we end up getting, we've got our 9.5 to 11 minutes, which again, 1 below and 2 above. And then our 9 to 10.5, which was 2 below and 1 above. So those groups were always going to give us that 81.5% there. And I should label these minutes. Same thing up here, minutes. But that wraps it up for our normal distribution. I'll see you all in our next lesson.